So I've been running lithium batteries. I've got 240 amp hour 12 volt system running. And I've had this system for well over a year now. I'll show you those in a minute. But whenever I'm plugged in, I've been charging off of the converter that came with this, which only runs about 15 amps. So not a whole lot of juice to recharge, which if you're plugged into shore power, not the end of the world. But if you have a situation where you're not getting enough solar to charge your batteries and you have to use this to charge them, then you're running a generator for really long periods of time. So this died a couple of weeks ago, and I tinkered with the idea of what I'm going to do to deal with this situation, because right now it's middle of winter time, it's cloudy. Just to give you an idea, this is what the weather has been for the last week. Rain, clouds, virtually no solar coming in. It's just been, there's mountains there, not that you can tell, but there's mountains there. So yeah, when you're running with this much cloudiness and all you've got is 600 watts, it's not quite enough. So it usually, if it's partly sunny, if I'm getting a couple of few hours decent a day, I'm in good shape. This not so much. So the way we've been mitigating that problem is with this guy here, and I've used him while I've been boondocking on and off for the last few years. It was honestly the cheapest one I could find that was enough to run the AC at the time. It was, I think I caught it for 500 bucks on sale on Amazon. It's actually done really well. 3200 watt inverter. It'll handle the surge of the AC. It's got the eco settings and whatnot. So really, it's done a good job. And lately that has been running my Amazon special smart charger. It's a 20 amp, and that goes to alligator clips on my bus bar. Yeah, wiring's a mess, deal with it. So again, I'm running off of this to charge my two batteries, and it's just not keeping up. I run the generator 7 hours a day, and it's like not quite enough, just leaving me a little less each day. The batteries, you can see them here, but I've got two 120 amp 12 volt lithiums, 100 amp BMSs. You'll see them better when they're, you can't really see them right now. So the project at hand was deciding what kind of converter to replace this with. And, I got looking, I was like, oh, I'll get 100 amp, I'll get 100 amp. Well, that's stupid. And the reason why that's stupid is because of this wiring here. See, this wire goes into your main board and comes out your main board, and it kind of shoots back into there and then through there and all the way back into there. And when you're talking about Ohm's law and how much amperage and voltage and things like that, wattage that a wire can handle, and you look at this and you go, well, it's a 6-gauge wire. And your math out and back, not just one way, I figured it out to be a solid 12 feet one way, so 24 feet round trip. At 14.3 volts, really, the best amperage I can run through this wire safely, because it's a 6-gauge, is 35 amps. So rather than going with a 100 amp converter to replace this guy and then burning the place down because I sent so much through there and it burns it out or burns out the board or whatever, I went with a 35 amp. And what I got, and I apologize for the lighting because I turned off the electric before and started doing this before I thought to film. Power Max 35 amp AC to DC, 3-stage smart charger. It's supposed to be able to handle lithium. You can also set it up for, fixed charging at a specific, voltage. I like the idea of the 3-stage. Kind of ramps it up as it's needed. So, but 35 is really, at the end of the day, that's the most amperage that I can send through these big fat wires safely that distance. Now, if I put the converter right next to the batteries, I could have gone with 100 without an issue, but that's not the case. And so we're gonna rather than rewire everything, rather than relocate it, because I'm not keeping this camper forever. We're just going to kind of stick it in the hole here. 35 plus the other 20 that I have set up, because I'll continue to use that when I definitely need to charge batteries. 35 and 20, that's 55 amps minus usage. It's probably 45 to 50 going into the batteries. That means I'm running the generator for 4 hours as opposed to 8 hours, and barely getting enough to cover yesterday's usage. So these things are pretty simple. Bother, where did I put it? Now these things are pretty simple. Basically you have the 3 wires there. That's your AC power. It comes with a plug, which I've chopped off. Especially a lot of the bigger campers, a lot of the newer campers, they have a plug, a dedicated plug, and it'd be somewhere in there. We didn't have that option. And I'm not going through the headache of wiring in a plug. So, when we chopped open the wire, they're color coded the same. Yay, makes my life easy. And then we have our positive negatives here that I don't have any 6-gauge wire, unfortunately, or even 8-gauge. I checked, all I've got is 10 from my solar build. So what we're going to do, since this thing's burned out anyway, we're going to go ahead and nip the wires right off the end of there, strip them back, and that'll cover the wires coming back into the board. Not my preferred method, but it's what we're doing today. So, I've already started by, pulling that apart. I'm going to kind of get this thing unhooked and then dry fit everything and go from there. So it's should be pretty cut and dry in theory. But every time I say that, it's not. So we're going to go ahead and set ourselves up.